Alright, we've got our bubble chart, and we understand what's going on with the measure names and measure values in the crosstab that sits underneath the bubble chart. Time to add our running percent of total. Remember the big picture here. We want to be able to add a filter that limits our bubble chart to a certain percent of all the Social Security cards. Since we've lined up our names from most to least common, we can start to explore how many names are actually used within a certain percent. So when we limit this filter to 50%, for example, we can see that 50% of the Social Security cards use only 148 of the 32,600 names in the dataset. All right, to make this slider, we can't just use a percent of total from occurrences because our visualization breaks down to the name level. Our filter would only go to 1.77% since that's how much of the total Social Security cards the most common name James accounts for. Instead, what we need to know about each mark is its running total and what percent of all the Social Security cards that running total covers. So let's build this first as a crosstab to make sure we understand what's happening, then we'll loop back around and add it to our bubble chart. To start, we'll take our occurrences variable and turn it into a running total. We'll click the drop-down menu, then quick table calculation and select running total. Let's also pull a new occurrences pill onto the measures card as well. We'll put it between our rank and our running total so we can see how the running total is working. Since we've sorted our names by the most to the least occurrences, the running total starts with James, and it's 4.8 million Social Security cards. And then on the next line, Tableau adds in John's 4.7 million cards, and the running total jumps to 9.5 when you put those two together. As we keep going, this running total allows us to see where certain thresholds are met. For example, we see that Paul puts us over the 50 million Social Security card mark, and then the rank helps us see that it only took 20 names to reach that point. But what we still can't see here is what percent of the total Social Security cards that 51 million cards represents. Now, we've worked with this data set enough to know that the total Social Security cards is 271,254,841. And sure enough, if you scroll to the very bottom of our crosstab here, that's the final running total. Now, we could manually divide the running total leading up to Paul by the total Social Security cards, and we'd see we're sitting just under 19% of the total Social Security cards. But let's create that percentage for all the names. This is the last piece of data we'll add to our crosstab. We'll transform this running total into a running percent of total. Head back over to your running total variable on the measure values card and click the drop-down menu and then click Edit Table Calculation. All right, first things first, we want Tableau to calculate the running total. But after it has that number, we want Tableau to then calculate the percent of total of that running sum. Here's what we'll do. Come down to the bottom of the box and click Add Secondary Calculation. Now our running sum calculation is still in place, and we can add our second calculation off that running total. We'll select percent of total and make sure the compute using is set to table down just like our running total. Let's exit out of our text box, and just to make it a bit easier to see what we've done here, let's add back in our original running total to our crosstab. We'll change the existing occurrences pill to a running total pill and add in a new occurrences pill to the crosstab. We can see the original number of Social Security cards for each name, how those cards contribute to the running total of all the cards that have come before it, and how that running total breaks down as a percent of all the cards in the data set. Between the rank and the running percent of total, we can easily see how many names it takes to reach a given percentage of the Social Security cards. 23 names gets us to 20% of the cards. 50 names accounts for 30% of the cards. Go to 90 names and you get 40% of the cards. But of course, finding these thresholds is the point of our bubble chart. So let's wrap up this step by adding our percent of running total to our bubble chart. Okay, here we go. We'll add our running percent of total to the tooltip first. We'll drag occurrences to tooltip and then click the drop-down menu and set up our running total. When we hover over our tooltip, we can see that our running total isn't calculating in the right direction yet. We know how to fix this by changing the compute using settings. So we'll come back to our drop-down menu and hover over the compute using. Now, in our crosstab, all our compute using directions were set to table down, which isn't an option here. But remember that table down in our crosstab was really just compute using set to name. Each row in the table going down was set to its own name, and the names were ordered by occurrences just like they are in our bubble chart. So instead, we'll change the table across setting to just name. Hover over the marks again, and we can see that our running total is now calculating in the right direction. Great, now let's turn that running total into a running percent of total. We'll come back to our table calculation, click on Edit Table Calculation, and add our secondary calculation. Set the secondary calculation type to percent of total, and here table down is in identical direction as name, so we'll select table down and X out of this pop-up box. Hover over the familiar center names, and this is where the crosstab we started with can serve as a helpful reference point. When we hover over a name like Charles, for example, and we see that 10th ranking and 13% running total, then we can come back over to our crosstab and double check that those calculations match what we have here. Good. All right, very last step. Let's make that percent of running total a filter. We'll just click on the pills drop-down menu and select Show Filter. We get our slider here, and notice that it only goes to 1.77% on the lower end. That's because that's the smallest running percent of total we have, since that's where the name James starts. Okay, now that it's all set up, we can actually play with this thing. If we cut our bubble chart down to just the first 50% of Social Security cards, we can see that just 148 names accounts for 50% of the Social Security cards. Or we could change this filter to just see the final percent of Social Security cards, the least common names, right? When we do that, all of those names that were sitting on the periphery before now come into focus. In fact, the last 1% of Social Security cards here accounts for 23,000 names. More than half of the unique names in the data set are sitting in that final percent. All right, great job sticking with me through all those nitty-gritty table calculations. On to the next step. It's short and sweet. Let's add a caption to this visualization.